Give me 7 minutes to show you the core steps and ideas behind building a simple AI application so you can shape your very first one. Hi, my name is Tianyi. Welcome to my channel. So an AI app by definition calls a large language model to do the work. Most of the time, we call models hosted in the cloud. Think OpenAI's GPT, Google's Gemini, pay as you go. So to do that, you go to the provider site, create your API key, basically a string that identify you, set permissions, and track usage. Just store it safely. Let's make a very simple AI joke generator. So first of all, you ask the app a question. The app preps your question and will check how in a second. And then send the prepared input to the model's API and includes your API key, and typically in the request header for auth. The model returns a response and post-process that responses and show it to you. So that's a big picture. Now, how do we prepare the input and polish the outputs? We usually send the user's original question, of course, and then a system prompt that says first the rules and functionality. Say you are a seasoned, upbeat joke writer who loves dark humor, right? The system prompt also set rules and boundaries, say answering under 200 words. And it clears tasks and goals. For example, your job is to reproduce a short, punchy dark humor joke, and then so the system prompt also defines output format. Say end each answer with one relevant emoji. And then we have temperature. Think of the model choosing the next word from a list of options with different probabilities. The low temperature means the model is safe and predictable, so it picks the most likely words a lot. And a high temperature means the model is bold and random, so it gives more surprising choices. And most apps use a range between 0 and 1. So we also have conversation history. Sometimes we include recent turns of chat history or a summary of it. But here for joke generator, we might skip history, so each joke is independent. But for some other applications, for chatbots, for support agents, or code assistant, actually history is essential. So how the application post-processing the model's output and give it to the client? There's some common steps. First, content check. So it removes some discriminatory or risky stuff. And guardrails. Okay, it answers only the questions within scope. For example, we have spot votes. We want it to stick to the product question and do not make casual checks with our client, right? And then we have the third post-processing is we often just extract some key information from the answer for LLM to, do some extra stuff, for example, to use tools, but that's more complicated topic we'll cover later. And we also sometimes reshape the answer of the LLM to JSON or other format, etc. Again, here our tiny joke application, we just really keep it simple and skip all these guardrails, all these steps. But if you want to do some other applications in different functionalities, in different contexts, you may need all of them. So now we have the overview of the whole workflow. Now the question is, how many lines of code we need for this? So answer is, you can get a minimum version in about 12 lines of code. Line 5 reads the API key. Line 6 creates the API client. Line 8 picks a model, and line 9 to 12 defines the system prompt, user prompt, and temperature. In this toy version, there's no really chat, just a fixed input, right? So if we write it up to a user's input, the user's prompt will change every time, but system prompt stays the same. The line 13 packs the system and user message. Line 14 sends the request and get a reply, exactly like the flow we described. So let's go one step further and make our application more robust. Timeout. Network hiccups happen. Set a max wait, for example 30 seconds, so the user gets a clear result even on failure. Retries with backoff. For temporary errors, retry after short delays. If it still fails, wait longer. For example, exponential backoff is often what we do, until it works or we reach a max, say 5 tries. Logging and monitoring. Record latency, token usage, retry counts. So this is basic observability and cost tracking. Read limit. Most public APIs cap your request, for example, 60 per minute. Sort of before you hit the limit so you don't get a wave of failures. So think of rate limiting as prevention and retries as cure. So let's go a bit further. Beyond temperature, many models expose extra settings. For example, max output token to cap length strictly. And GPT-5 even allow you to adjust reasoning efforts between low, medium, and high. Also, you can add some moderation guardrails to keep output compliance and on topic. So that's the core logic of the simple AI application. And I hope you learned something from it. You might be thinking, okay, I get the idea, but how do I actually implement and control the details? My take is pick a code generator you like. Codex, Cloud Code, Cursor, whatever. And then first of all, ask it to generate this tiny text-based AI app, just like a joke generator. Run it and make sure it works, and check how the code is written. Then come back and add one feature at a time. Timeout, retry, login, history, guardrails. After each addition, run it again and read what has changed. So in this way, you are building a real project while letting AI boosting your learning curve. I'm Tianyi. If this video helped you, don't forget to like, comment, subscribe. And how do you think this learning by shipping approach? Tell me in the comments.